Hey seniors, I'm so excited that we have this extra hour to prepare for our benchmarks. So I'm going to go through a bunch of different review problems with you, and then you guys are going to have time to practice immediately after. These topics are not going to be in any kind of order because that's how it's going to be on your benchmarks. So I really need your attention. I really want us to dive in so we can get an extra hour in of really good benchmark practice. So we're going to start with rational numbers. And you'll remember from class that a rational number is anything that can be written as a fraction or a number that terminates or repeats. So let's go ahead and do an example. If I have 3/4, it's a fraction, so I know that it must be rational. If I was to rewrite it as a decimal, it would be 0.75. And since 5 terminates in the hundredths place, I can say that this is a rational number. Let's do another one. If I had 0.444 forever and ever, never, 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 even though this number does not terminate, I see that the 4s repeat. And since the 4s repeat forever and ever and ever, rational. Irrational numbers. They do not repeat and they do not terminate. So if I had 3.5, 6, 7, 8, 9, 2, 3. You see how none of these numbers repeat themselves? And since they don't repeat, it's irrational. And you can also see that this number does not terminate. It goes on forever. The most famous example of an irrational number that you'll recall from class is pi. Whenever you see pi, it's always irrational. So if I had 3 pi over 4, yes, this is in fact a fraction, but because of the pi symbol, it is irrational. And this also cannot be written as a quotient of integers, and you'll recall from Quizlet vocab that quotient of integers just essentially means an answer to a division problem with rational numbers. And since this is an irrational number, it does not qualify as a quotient of integers. All right, let's go ahead and move on. Scientific notation. In this particular example, we're just going to be expanding in standard and scientific. So if I have 5.4 times 10 to the 4th, you'll recall that the exponent tells me which way I'm going to move my decimal. If it's positive, I know that I'm moving it right. If it's negative, I know I'm moving it left. So my first thing is to pull out my coefficient, which is 5.4. I know from my exponent, I'm moving my decimal 4 places to the right. So let's go ahead and scoop. 1, 2, 3, 4. Drop off my decimal, fill in my zeros. So my new number is 54,000. Cool. Let's put a number in standard notation back in scientific notation. This example, 0.000345, I can already see that this number is less than 1, so that means that my exponent is going to be negative. So let's go ahead and move our decimal. Remember, I'm moving my decimal until I have a number that's between 1 and 10. So let's go ahead and move it. 1, 2, 3, 4. Drop off my decimal, pull out my new coefficient, and because I moved it 4 spaces to the right, I know that I have an exponent of -4. And I know it's negative because this number was less than 1. Let's move on. All right, add and subtract in scientific notation. You'll recall that in order to add and subtract in scientific notations, your exponents absolutely have to be the same. So that needs to be the first step that you look at in these examples is, are my exponents the same? So let's do our example. 4.5 times 10 to the 3rd plus 3.4 times 10 to the 2nd. Immediately I see that my exponents are not the same. So I know I have to change them in order to make them the same. And the way I do that is I remember my good friend Lars. If I want to move my decimal, if I want to add 1 to my exponent, I know I have to move my decimal to the left. So I know that I'm going to keep 4.5 because it has the larger exponent. But let's go ahead and move 3.4 1 space to the left, and that means I can add 1 to my exponent. So my new problem is 4.5 times 10 to the 3rd plus 0.34 times 10 to the 3rd. My last step here is just to add my coefficients. So let's go ahead and do that. So I have 4.5 plus 0.34. I line up my decimals. I fill in my zeros. 4 plus 0 is 4. 5 plus 3 is 8. Bring my decimal down. 4 plus 0 is 4. So my answer is 4.84 times 10 to the third. And you go through that same process with subtraction. Are my exponents the same? If not, I have to change them. All right, if I want to multiply in scientific notation, I just have to multiply my coefficients and then add my exponents. And you'll remember our MADS rule. If you're multiplying, you add. If you divide, you subtract. So all I have to do here is multiply my exponents. So let's do that. 9.4 times 1.2. And you'll remember from math intervention, I ignore my decimal. 4 times 2 is 8. 2 times 9 is 18. 0 placeholder. 1 times 4 is 4. And 9 times 1 is 9. 0 plus 8 is 8. 8 plus 4 is 12. Carry my 1. 9 plus 1 is 10 plus 1 is 11. So I'm coming out with 11.28 times 10 to the, and then I remember my MADS rule, and I know I have to add my exponents. So I have 11.28 times 10 to the fifth. Let's go ahead and do one with division. If I want to divide, I know that I follow the same process. I just divide my coefficients and I subtract my exponents. So if I were to divide 9.6 by 3, I would come out with 3.2. And then of course I know that I subtract my exponents. 3 minus 2 is 1. So that's all I'm left with. Oh, and actually, you guys will notice that I actually made a mistake up on this top one because I left my coefficient as 11.28. And in scientific notation, you know that it has to be between 1 and 10. So if I want to move it one place to the left, if I move my decimal one place to the left, I have to add 1 to my exponent. So my number should be 1.128 times 10 to the 6th to get it in proper scientific notation. Hopefully you guys caught that. All right, let's do some exponent laws. Again, MADS. If I multiply, I add. If I'm dividing, I subtract my exponents. So in this first one, I see 9 to the third times 9 to the fourth. I see that I have the same bases, so I'm going to go ahead and rewrite my base. All I have to do then is add my exponents. 3 plus 4 is 7. Now, if I see two numbers squished together like these are, I always know that that means multiply. So bring my base out. 3 times 10 is 30. And let's do one more. If I'm dividing, I have the same base, rewrite my base of 9, and then I just subtract my exponents. So I come out with 9 to the 6th. Don't miss those, guys. Those are easy ones. All right. If I want to find the square root of 17, I know that 17 is not a perfect square. So I need to estimate to figure out where it falls on a number line. And my first step is to figure out what are my perfect squares that are around it. Well, I know that 16 is a perfect square and that 25 is a perfect square. So I know that the square root of 17 is going to fall somewhere between 4 and 5. But since 17 is way closer to 16 than it is to 25, I know it's going to be closer to 4. And you'll remember, if it's closer to the smaller integer, my decimals are going to be either 0.1, 0.2, 0.3, or 0.4. I'm going to go ahead and try 4.1 because I know that 17 is pretty close to 16, and we want to get as close as possible. All right, 1 times 1 is 1, 4, 0 placeholder, 4, and then 16. Add my numbers, 16.81. That is pretty close to 17. I can go ahead and say that 4.1 is a good estimate. If I wanted to place the square root of 17 on a number line, let's say that this is 1, 2, 3, 4, 5, and 6. I know that 17 falls between 4 and 5, so I can just put a dot close to 4 and write the square root of 17 above it. All right, repeating decimals. If I want to turn 0.44 into a fraction, I know that the first thing I have to do is identify which numbers are repeating. In this case, I see it's the 4. So I can go ahead and set x equal to 0.4. And again, I see that this is repeating. So, and actually this bar should just be across the first number. It goes on forever. All right, my next step is I need a new equation. So I have to multiply both sides by 10. And that brings me to 10x equals 4.4. And then I just subtract my old equation from my new equation. I come out with 9x equals 4 if I'm subtracting down. 10x minus x equals 9x. 4.4 minus 0.4 equals 4. I got to divide by 9 to get x by itself. So the answer I'm coming out with is x equals 4/9. That's literally it. If I want to turn a fraction into a repeating decimal, I go through the same process that we learned in math intervention. Top in, bottom out. 1 goes in, 3 goes out. I know that 3 doesn't go into 1, so I need to go ahead and put a 0. I have a decimal I can bring up. 3 still doesn't go into 1, so I know I have to add a 0. 3 does go into 10 3 times. 3 times 3 is 9. That leaves me with 1. 3 doesn't go into 1, so I got to bring a 0 down. 3 does go into 10 3 times. 3 times 3 is 9. Left with 1. You guys could see that I could do this all day long, but it's always top in, bottom out, and I can represent my answer by just putting 0.3, putting a bar over it, and that's my decimal. All right, guys, that's going to be it for me. I am so glad that we got this hour to review, and I think we're going to crush the benchmarks. I'm super excited about it. As you guys know, always ask me if you have questions. Call me if you have questions on homework, and I'm super excited. Thanks, guys.